Let's start. Okay. Okay. Welcome everybody to our webinar on the presentation of the 2022 Blue Book on China's concentrating solar power industry. I'm very happy to welcome you all here and to introduce also Fengli Du from the Secretary of National Solar Thermal Alliance, who will present the Blue Book, and Professor Zifeng Wang, who will give a few welcome words. And I have the honor to moderate this meeting, and I would just like to give you now a very quick overview on Solar Paces. Probably most of you know Solar Paces. It is a technology collaboration program which runs under the umbrella of the International Energy Agency. And as an international network of stakeholders from research, industry, and policy, it supports international collaboration to advance development and deployment of concentrating solar thermal technologies, and organizes meetings and events to disseminate knowledge about this technology. Currently, we have 17 members that you see on this map. And let's go to the tasks that Solar Paces is performing. The work is organized in 5 tasks currently. Task 1 deals with the analysis of CSP plants, modeling and simulation. We have efforts now going on with hybridization of plants, running CSP and PV together, for example. Task 2 deals with solar fuels and chemical commodities, for example, the generation of hydrogen via thermochemical pathways. Task 3 is about component development and qualification, and a large activity now within Solar Paces community is the preparation of standards and guidelines to work in the further dissemination and availability of standardized components. Task 4 is dealing with process heat for industrial and residential applications. And task 5 is dealing with the solar resource assessment of direct normal irradiation and forecasting systems for improved plant operation. One of our major efforts every year is the organization of the annual conference. Our next edition will be from 10 to 13 October in Sydney, Australia. You see here the website. You will find all information on the website of the conference. And I would be really happy if we can welcome many of you to the conference, where you also will be able to learn certainly a lot about more progress in China in CSP. And just to remind you, currently the call for papers for abstracts is open since February 27. It will stay open until May 5, and this is an opportunity to inform and share your work in scientific and technological developments in academia and industry. We accept a notification of acceptance of the abstracts in mid of June, and in August, start of the online registration. And from October 10 to 13, we will have the conference. And with this very brief overview, I would like to give the word now to the presentation of the Blue Book. So maybe, I don't know, Zifeng, would you like to say a few words, or should we go directly to the Blue Book?
Only introduce directly.
Okay. Well, then it's my pleasure to introduce here Fengli Du from the Solar Thermal Alliance, and she will give us the presentation of the Blue Book. And I think after that, we will have the possibility to answer some questions. For questions, please use, as usually, the question and answer section of the Zoom meeting. And well, with this, I would like to give the word to Fengli, please.
Thank you, Christoph. I would like to share my screen first.
Yes. Perfect.
Now
presentation mode.
Dear all,
yes.
And good afternoon and good evening. I'm Fengli Du from China Solar Thermal Alliance, short term known as CSTA. I'm glad today I will present the Blue Book of China's CSP Industry 2022. CSTA was established in 2009 and was evaluated by most Ministry of Science and Technology of China as a Class A alliance in 2012, with Professor Zhifeng Wang of the IEECAS as the founder. CSTA is engaged in promoting the CSP and solar thermal industry development, with more than 160 members nowadays, and covering the whole value chain of CSP. In order to provide the reference and the data support to the government decision making and to the industry, CSTA started the Blue Book editing since 2015. And from last year, we started to translate the Blue Book into English for the international communication. Last year's Blue Book was guided by Professor Zhifeng Wang. He is also the chairman of CSTA. He is the leader of the first megawatt solar tower plant and parabolic trough demonstration projects in China. Now he is the chief scientist and leader of the supercritical CO2 CSP R&D project in China. The Blue Book on the CSP has 7 chapters for the English version. In Chinese version, we also included the contents of the life cycle carbon emission of CSP plant and the appendix, including the development history of CSP industry in China and the supporting policies issued in 2022 and the national standards and the winning companies of CSP projects last year. By the end of 2022, China's CSP installation capacity reached 588 megawatts, including all the megawatt level CSP plants with steam turbine. Last year, we have 1 beam down solar tower project into operation with a capacity of 50 megawatts. And nowadays, we have 11 CSP demonstration plants on grid with a total capacity of 570 megawatts. In Qinghai, it has 5 projects, and in Gansu province, it has 4. In the Mongolia and the Xinjiang region has 1 respectively. Among all the installed CSP capacity, solar tower accounts for about 63%, and parabolic trough is about 26%, and we have 1 linear Fresnel with a 50 megawatt capacity and 15 hours of TS. In the Blue Book, we presented the operation performance of the national CSP demonstration projects. And as you may know, the National Energy Administration launched the 20 CSP demonstration projects. By the end of last year, we have 9 put into operation. The first one is the CSMP in the Mongolia 100 megawatt PT plant. The plant is located at a high latitude of 41.5 degrees, and in the year of 2022, it generates the electricity of 310 gigawatt hour. It achieved 12 days without shutdown, and the inception rate of the collector reached 98%, tested by the European third-party authority laboratory. It has 10 hours of thermal storage. Shouhang Dunhuang 100 megawatt solar tower plant generated about 197 gigawatt-hour of electricity, which is lower than the expected value because of the malfunction of the steam turbine. Nowadays, the plant only can operate at a maximum safe load below 60% because of the steam turbine. But it realized 263 hours of non-stop operation, and the self-power consumption rate was reduced 1% in last year. Qinghai Songpeng Solar 50 megawatt tower plant reached the design value of 100%, generated 146 gigawatt-hour of electricity. And if excluded the fact of shutdown for 10 days due to the grid maintenance, the power generation last year could be 3 points higher than the design value. It's the first plant in China reached the design value. CGN Delinha 50 megawatt PT plant utilized hour in last year is 2,414 hours, and it operates continuously and safely for 230 days from September 19th, 2021 to May 7th, 2022. It has 9 hours of TES. Power China Gonghe 50 megawatt solar tower plant didn't share the operation data in the report, but they do submit the data to the National Energy Administration for supervision. It has some problems in operation, like the mirror soiling and cleaning techniques, and the molten salt pump malfunctions, and as well as the steam turbine. Sorry. DCTC Dunhuang 50 megawatt linear Fresnel CSP plant is the world's first of this kind, and that achieved commercial operation. On May, June, and July of last year, the monthly generation exceeded 10 gigawatt-hour, and the total power increased by 45% compared with that of 2021. Luneng Gurnud 50 megawatt solar tower plant is one part of the integration renewable energy demonstration project. It also has the 200 megawatt of PV, 400 megawatt of wind power, and 50 megawatt of battery storage. In 2022, the plant generated 86 gigawatt-hour of electricity, and the maximum monthly power generation is about 10 gigawatt-hour. Energy China Hami 50 megawatt solar tower plant didn't share the operation data neither for the report, but they do share the total investment data. It's about 1.58 billion renminbi yuan. It has 13 hours of TES. The Bimdang power plant has a capacity of 50 megawatt. It's connected to the grid on March of last year. It's still under commissioning nowadays. In the last 2 years, China has, the government has issued the new CSP policies, and which define its position in the energy mix. For example, the National Development and Reform Commission stated since 2021, no feed-in tariff for newly approved CSP plants project instead of the benchmark price of as the local coal-fired power plant, which is very low, is about 0.3 yuan per kilowatt hour. And the qualified projects needed to be market oriented and through the competitive allocation. The State Council issued the action plan for peak CO2 emission before 2030. It stated to actively develop CSP, promote the establishment of integrated renewable energy power generation base with the complementation of CSP, wind and solar PV power generation, and to build a new power grid system. The NDRC and the National Energy Administration also emphasized the CSP projects construction to use CSP as the peak-shaving power source. And in the 14th five-year plan for renewable energy development, issued last year by 9 ministries and commissions, also emphasized to build CSP plants with its long-term TES capacity and to give full play to the energy storage and regulation capacity to support the grid system with the CSP plant. Under all the guidance and support of the relevant national policies, there are currently 29 CSP projects with a total installed capacity of about 3.3 gigawatt hour developed and integrated with PV and wind power. These are expected to put into operation by the end of this year or next year. These projects are configured as one CSP to 6 solar PV or wind power. Use the low cost of PV or wind to compensate the high cost of CSP. But the electricity price of this hybrid plant or the renewable energy base is the same as a coal-fired power plant. Nowadays, about 10 CSP projects have finished the EPC contractors or key components bidding. We had the list of the ongoing new CSP projects in Xinjiang, Qinghai, Gansu, and Jilin province. Xinjiang region has the largest announced capacity. It has 13 projects, and Qinghai has 9, Gansu has 5. But because of the low electricity price in Qinghai province, these 9 projects are the progress is rather slow. We also listed the project in each province. For example, in Gansu province, the Jinta 100 megawatt CSP plus 600 megawatt of PV projects developed by Kosan Solar has the fast progress in construction, and the solar tower has finished its capping, and it's expected to finish all the installation by the end of this year. And Songsam is developing the 100 megawatt CSP plus 200 megawatt PV and 400 megawatt wind power in Guazhou Jiuquan City with 3 gorges, Gezhouba group. And also in Aksay, we have 110 megawatt solar tower. In Yumen, the 100 megawatt linear Fresnel project is under construction. In Qinghai Province, several projects announced the EPC contractor, like the Concern Solar and the Shouhang Consortium. In Xinjiang region, it has, as I said before, it had 13 projects, and some of them are doing fast in progress. Some announced the EPC contractor. Most of them are using tower technology. In addition, in Tibet region, as Tibet is in an isolated grid system, so they are develop some CSP supported energy support source and use parabolic trough as the CSP type. We also account the market players in China's CSP industry chain, and nowadays we have about 600 players or companies in China, and the direct and indirect employees in the industry are about 59,000 people. And the manufacturing capacity of key product components can support at least 3 gigawatts of CSP projects per year. And we also listed the main players in China's market, and the English table can be found in the annex of the Blue Book. In terms of the R&D projects, and the Ministry of Science and Technology are supporting some research projects. The first one has finished the project last year, and they are still under researching. For example, the supercritical CO2 CSP basic problems. The project is expected to build the 200 kilowatt demonstration system in Yanqing of Beijing, in IEECS solar CSP base next year. And the wide wave plane super surface solar concentrator and its collector system project coordinated by Wuhan University of Technology will develop a revolutionary concentrator, and which is totally different from the current heliostat or parabolic trough. Last year, the most announced the new project to develop the special alloys for high temperature molten salt system for CSP plants, which is coordinated by the Mental Research Institute of Chinese Academy of Sciences. This project, named coordinated by Xi'an Jiaotong University, will develop the solar thermochemical conversion and energy storage system. I also listed some technical requirements in this project. For example, the reaction temperature will equal to or higher than 700 degrees C, and the conversion rate of a reaction unit will be higher than 80%. Last year, we have 3 international cooperation projects funded by the Ministry of Science and Technology. 2 of them are coordinated by the IEECS with the United States, cooperated with the United States. One is on the high temperature molten salt storage tank for CSP and life prediction, and another is for the solar desalination with CPC concentrator. And the third one is between China and Spain to research on the secondary reflective solar tower PV combined power plant. The Blue Book of last year also have some analysis on the investment cost of a solar tower plant and solar parabolic trough. We have 50 megawatt solar tower with 7 hours TS and 100 megawatt solar tower plant with 12-hour TS. The investment composition is listed. Here is the investment cost composition of a parabolic trough plant. And in the Blue Book, we also analyzed how to promote the CSP development in China. One way is to reduce the initial cost and OM cost. The potential ways to reduce the cost of CSP include we can from the solar field, solar receiver system, and some storage system. Each item can contribute to the reduction of power plant cost. And another way is to improve the efficiency. And the items should be optimized from the point of view of the project engineering, including the heliostat field cleaning. For example, in the Dunhuang city of Gansu province, it has a very the storm or the dust is very heavy. How to maintain the cleanness of the field is a very important, and it's the key to reduce the cost of O&M and improve the reflectivity. For the existing molten salt tower plant, by optimizing all parts listed in the figure, the efficiency of a CSP system could be improved by 12% to 27%. And the economic improvement due to the optimal scale can increase the value to reduce the cost by 2 cents. In the last, and we also put forward some suggestions to promote the CSP in China, including the research and engineering. For example, to keep on research on the supercritical CO2 CSP technology. And the full report can be downloaded from CSTS website and Solar Pieces. And I hope you can get some reference from the report. That's all for my presentation. Thank you very much.
Yeah, thank you so much, Feng Li, for this very detailed presentation and this very nice overview, and for being up so late to share these developments with us. There was one question regarding sharing of your presentation. I mean, the idea is, like we did last year, to make the recording of this webinar available on our YouTube channel. So you can access it in any case, and the Blue Book is available for download on the Solar Paces website and on the National Solar Thermal Alliance website, as Feng Li just pointed out. Well, so you should have access to this in any case. I am now wondering if there are any questions from our audience that you would like to formulate in the question and answer section. and maybe we can answer them right now. If there are no questions right now, please feel free to drop me an email and I'll get you in touch with our speakers. Okay, I see here one question. Mark, let me read it. Are any of the Chinese plants willing and able to share minute-by-minute performance data on their plants, instrumented throughout the plant? Fangli, can you see the question as well? There.
Hello, hi, Mark. From my understanding, probably no owners would like to share, but we can check.
Yeah, it's a long discussion, and we know that this would be very, very important to share this information and to be able to make more detailed modeling. And so, yeah, it would be great if it would be possible.
We only have 2 owners who would like to share the monthly generation instead of the minute by minute. But some are still working, by improving the commissioning each part of the system.
Okay, so that's something to follow up, I think. Now, let me read the question from Jürgen Gradl. Many of the 30 plants are supported to be finished in 2023-24. Is this still realistic?
We can, how to say, it's the plan, and I checked with the developer. It's not very realistic, but next year there must be some could be put into operation. For example, we develop the integrated renewable energy base, but some access point to the grid are not ready, and even the project is finished, but they cannot put into, connect to the grid. Apart from the factors of electricity price, the support policy, there are also some we call so hardware, from the grid side. So not very realistic.
Okay, thank you for that assessment. And you see the next question from Mark. Can you speak toward the reliability of hot tanks within your Chinese-based tower plants? Hot tank reliability has been an issue with many tower plants outside of China. Do you have any information there?
For my knowledge, the hot tank, we haven't occurred any problem on the hot tank, but it had some problem on the molten salt pump, especially on the top of the tank. For example, the cold pump has some vibration, and they needed to solve that problem. But for the hot tank itself, so far, no problem reported yet. Maybe, we don't have the plant just put into operation for not very long time.
Okay, thank you. And there's one question. Do you have insight of the operational status of the 15 megawatt Fresnel CSP plant in Zhangbei, based on direct steam generation and concrete thermal energy storage?
It's a pity that project didn't finish the access to the grid. I mean, the power transmission line from the plant to the grid, the owner or the grid didn't build. So the project itself only operated to test the concrete thermal storage. Now they transformed this project into an integrated solar hybrid plant to build a 50 megawatt PV along, near this project. They hope they can do the integrated operation.
Okay, thank you very much for this answer. And next question is, after the FIT policy has been removed, do you believe it is possible for CSP to further reduce construction costs, therefore make it a competitive technology in China?
Since nowadays the CSP is built as a complementation, or to hybrid with the solar PV and wind power. In fact, it's not act like the standalone project. So the heliostat field, or we can say the concentrator field, is reduced since it take a lot, 51% in the cost. So now they reduced the cost, they reduced the area of the heliostat field. So the total cost is reduced at the same time. So and I checked with the developer, and with for example, with the half of the heliostat field, it can achieve the function the government want the plant to play. So it's the one way to do when after the feed-in tariff was removed. But some some developers are reducing the field size too much, and that's not what we want to see, unwilling to see. So we proposed, to the government, try to make clear on the function of CSP. And nowadays they want to use CSP as the peak shaving, and but if with very small heliostat field, and we may not have too much energy when it's required by the grid. And we are afraid that someday in the future, the grid may be disappointed about the CSP role in supporting the grid system because of the reduction of the solar field.
Okay, let's see. I mean, you have shown some analysis where cost reduction could be achieved, so hopefully this can be realized over time, and the 3 gigawatt production capacity per year can be rolled out at some point. There is a next question also regarding cost questions. Can you elaborate on the 1:6 or 1:9 CSP to PV ratio, how it can reduce the overall cost?
This ratio, I'm not sure exactly this ratio is rational or not. But in Gansu and Xinjiang province, they are doing this. 100 megawatt CSP with 600 megawatt or 900 megawatt PV. And as you know, PV has the low cost, and low cost like 20 cents. But the feed-in tariff of the coal-fired power plant is, let's say in Gansu province, is 30 cents. So if the PV can generate more power, they can earn more. So they can compensate the cost of CSP. And just now I said they also reduced the solar field to reduce the cost of CSP itself. So with the reduction of CSP itself, and plus the more income from solar PV, so the total cost can be reduced.
Okay, I see. So I don't see more questions right now, and given the late time also in China, I would propose to close the webinar now. Again, please, you have our contact data. If you have further questions, just drop us an email. I would like to thank very, very much Feng Li for the presentation and all the answers given here. I would like to thank very much to our audience from all over the world in different time zones to join us. And yeah, look out for the, let's say, publication of this webinar. And also the great chance for all of you and for all of us is to share information on CSP development in China and elsewhere in about 6 months in Sydney in Australia when we have our annual conference. And it would be great to see you there. Okay, with that,
Okay.
Thank you again, Feng Li, and thank you again, Zifeng.
Thank you for your time. Thank you all.
Thank you. Goodbye, good night, good day. Bye.